So hello students, welcome to ePhysics. Students, in this video we will be discussing which is easier, to push an object or to pull an object. We will discuss pushing an object and pulling an object differently. So here we will be starting with pushing the object. Example of pushing an object. Now let's consider that we have an object. Okay, we have an object. Here, if we push this object, what will happen? It will start moving in any direction. Okay. Now, if we draw the free body diagram, we can see it over here. That when the object was being pushed, it was moving in the horizontal direction, and the force applied on this point was on this direction. If we consider this angle as theta, we can write this, and let us consider the force applied was F. Okay, F. Then the component of force along the horizontal will be F cos theta, and the component of force along the vertical direction will be F sin theta. Is it clear? I hope so far it is clear. Now let us consider the mass of the object is m, then the weight of this object will be in the downward direction, that is m into g. Whenever the object is moving, okay, there will be a frictional force. Displacement is in this direction, and opposite to the direction of the force there will be the force known as frictional force. Okay. Now whenever we talk about friction, there is always a normal reaction perpendicular to the direction of the force. Let us consider this is n. Here, now students, we know that this normal reaction will be equal to n will be equal to mg in the case of push mg, and we can see over here as well that f sin theta is also in the downward direction. Therefore, it will be equal to mg plus f sin theta. Why we are considering mg plus f sin theta? Because the movement along the vertical axis is 0. The object is not moving in upward or in downward direction, it is only moving along the horizontal direction. Therefore, the movement of the object along the vertical direction will be 0. Therefore, we can consider it as that this normal reaction will be equal to the downward force, that is f sin theta plus mg. Clear? Now, we know that frictional force is always equal to, let us consider this frictional force is 1, which is equals to nu into n. Therefore, we can write it as nu into n will be substituted with mg plus f sin theta. Let's consider this is equation 1. Okay. Now let's move to the example of pull. Okay. Now let's move to the example of pull. Now students, if we have any object and we are pulling it, okay, this is the direction of the force applied. This will be the direction of the movement of the body. Let us consider this is making an angle theta. Therefore, the component of the force along the horizontal axis will be f cos theta, and the component of the force along the vertical will be f sin theta. Is it clear so far? Now, what we can learn from here, that we know that let us consider the mass of the object is m, therefore the force in downward direction, that is the weight, will be equal to m into g, and we know that we have n as a normal reaction. Whenever we consider about frictional force, we consider n that is perpendicular to the direction of the force applied, that is f cos theta over here, because the movement is along the f cos theta. Here the movement along the vertical axis is again 0, therefore f cos theta, sorry, not cos theta, it will be sin theta. This is sin theta in the vertical direction. F sin theta plus n will be equal to m into g. Okay, m into g. So we can write it as n is equals to mg minus f sin theta. And we know there is a frictional force always in the opposite direction of it. Let us consider frictional force is F2, which is equals to nu into n, which can be written as nu, and will be replaced as mg minus f sin theta. Let us consider this is equation 2. And in equation 1 and in equation 2, when we compare these two equations, we can clearly see here that in F1 it is plus sign over here, and in F2 it is negative sign over here. So we can clearly say that the frictional force 1 is greater than frictional force 2. That is, the frictional force in the case of push is greater than the frictional force in the case of pull. Since the frictional force in the case of push is greater, therefore it will be difficult to move the object in the in the opposite direction. That is, in the case of push it will be difficult to move the object, and in case of pull it will be easier. Clear? So whenever we push or pull an object, it is always pull that is easy to be done. Okay, so I hope you understand the video nicely. Thank you very much.